My name is Siddhant and I'll be your interviewer today. Now, I would like you to introduce yourself and please tell me why do you think that you're a good fit for this particular role?
Hi, my name is Amita Banerjee. I'm a recent computer science graduate from Pune University. During my time in high school, I was deeply interested in Python, which is where I started to learn more about it and do projects in it. All of my experiences until now have helped me hone my technical skills and my logic building and understanding that goes into building complex, clear, and easy to maintain code. I enjoy the versatility that Python provides, and it's the same versatility that allowed me to implement projects such as complex algorithms, manage databases, and develop user-friendly applications. I believe my past experience in Python and the data field, along with my projects, my internships, is what makes me a strong candidate for this job, since I have practical experience when it comes to working with code and I'm capable of working with the team well.
Well, that's a very good introduction. Now, I wanted to know that what attracted you to Python and how do you use it in your projects or studies?
I was initially attracted to Python because of its easy to read syntax and how easy it is to code. Since I started learning Python in high school, this was a big plus point for me. And as I moved forward, what really kept me engaged was how Python is used for data analysis extensively throughout the world. It makes sense as world economies grow, consumption increases, businesses will grow. As business grow, data grows, and if data grows, data analysts and data scientists are required more and more. Therefore, I believe Python will be the language for the next few generations. In addition to this, I got even more exposure to Python during my academic projects when I used pandas for complex data analysis and when I used scikit-learn to build a machine learning model for predicting images and text. These experiences not only solidified my ability to code in Python well, but it also gave me an understanding of how vast Python is and how well it can be adapted to different domains and different industries.
Excellent. Let's move on to some technical questions. How do you create and import a user-defined module in Python? And once you've created the module, how would you package it into a real file for distribution?
Creating and importing a user-defined file in Python is extremely straightforward. You start by writing your code in a file that has a .py extension. Let's take an example and see how it's done. Over here, we're going to create a Python file called mymodule.py. Within that, we're going to create a function, my function, and within that, we're going to add hello world. Now, on the same computer, if you want to access this function or this file from a different file, we'll do import my module, thereby importing this file and printing it. Now, let's say I want to utilize this function and I don't want to just import it on my laptop, but I want to make it importable on everybody's laptop. In that case, I will have to create a package. To create this package, I'm going to create it by this name. In order to distribute mymodule.py to anyone who wants to use it, I have to turn that file into a package. In order to set it up as a package, I'm going to create setup.py and here is the configuration I've placed for this package. In order to turn a file into a package, I need to utilize the setup module from the setup tools package of Python. Once this is done, you open up command prompt and type in python setup.py bdist_b. This will convert your file to a package. Now, remember, when you're typing this line into command prompt, you need to make sure that you are referencing the file you have created over here.
Well, thank you for the clear explanation. Moving on. How do you define a class and create objects in Python? And I would like you to describe the concept with the help of an example.
Certainly, in Python, a class is defined by using a class keyword. It serves as creating a blueprint for the object. A class contains attributes and these attributes are variables which basically hold data. It also holds methods which are functions that define how this data is going to be executed. Here's a simple example to illustrate. Here we have a class named cat and here we have our constructor function which takes into account two parameters, the name and the breed, which we have defined over here. Self.name is name, self.breed is breed. This essentially means that every object that is created will have two parameters, name and breed. This function over here returns a string. So here we create an object called myCat where we have assigned a name and a breed. We then go ahead and call the print function, and within the print function we are calling the second function which is def sound, this string over here, right? And over here, since we have added the object myCat, it will call the two parameters within that object which is buddy and houseCat. As a result, your output will be buddy says purr.
Now, what's the difference between an iterator and a generator?
An iterator is an object that implements the iterator protocol, which consists of the methods iter and next. An iterator must have both of these methods, iter, which returns the iterator object itself, and next, which returns the next item from the sequence, raising a stop iteration exception when there are no more items. Iterators allow us to traverse through all the elements of a collection, such as lists or tuples, without relying on indexing. A generator, on the other hand, is a special type of iterator that is defined using a function rather than a class. Generators use the yield keyword to produce a series of values lazily, meaning they generate values on the fly and maintain their state between successive calls. This makes generators more memory efficient, especially when working with large data sets or infinite sequences. Here's an example to illustrate the difference. Over here we have a class called myIterator, where we have a constructor function that defines the parameters of the function. Then we include the iter and the next methods. Within here, we define what is happening in the next method, the parameters, what. Then we take a look at what if it doesn't happen. As I said before, if this does not take place, it will raise stop iteration. And over here, we are creating the object myIter. Now let's take a look at the generator example. In the generator example, we don't need to build a class. We can utilize the function in itself in order to get the successive calls that we require. This is great because it's especially memory efficient and it is easier to code than the iterator.
Can you explain what decorators are in Python and provide an example of a simple decorator?
Decorators in Python are powerful features that allow you to modify or enhance the behavior of functions and or methods without changing the actual code. A decorator is essentially a function that takes another function as an argument, adds some functionality to it, and then returns a new function. Decorators are commonly used for logging, access control, memoization, and more. Let's take a look at an example for this. In this example, my decorator is a decorator function that defines an inner function wrapper. The wrapper function adds additional functionality before and after the original function. The add my decorator syntax is a syntactic sugar that applies the decorator to say the hello function. When say hello is called over here, the output would be something is happening before the function is called hello, something is happening after the function is called. This shows how the decorator adds behavior before and after the execution of say hello without modifying its code directly. Decorators can also take arguments, allowing for more flexible and reusable modifications to function behavior.
What tools or methods do you use for debugging the Python code?
For debugging Python code, I use a combination of tools and methods to identify and fix issues effectively. Number 1, print statements. One of the simplest and most common methods is using print statements to output variable, values, and program flow. This helps in quickly identifying where the code might be going wrong. Second, we have logging. The logging module provides a more flexible way to log messages after different severity levels: debug, info, warning, error, and critical. This is particularly useful for larger projects where print statements are not manageable. Thirdly, we have PBD or Python debugger. The built-in PBD modules allows interactive debugging. You can set a breakpoint, step through code, inspect variables, and evaluate expressions. Here's a basic example of using PBD. Over here, we import PBD and we add it to this, and then we create a function, def faulty function, with the parameters of x and y. As you can see over here, we do pbd.setTrace, we ask for the result, and then we do faulty function. Let me explain what's going on here. When you run through this code, it will enter the interactive debugger at the breakpoint, being over here, allowing you to inspect and step through the execution. Next, we have IDE in editors. Integrated development environments like PyCharm, VS Code, and Jupyter Notebooks offer advanced debugging tools. They allow setting breakpoints, inspecting variables, and stepping through code with graphical interfaces, making debugging more intuitive. Next, we have unit testing. Writing unit tests using frameworks like UnitTest or PyTest helps catch bugs early by ensuring that the individual pieces of code work as expected. Running tests frequently can help identify when and where new issues are introduced. Combining these tools and methods provides a robust approach to debugging, ensuring that you can effectively identify and resolve issues in your Python code.
How do you interact with a database using Python? And could you please provide me with an example using a library like SQLite?
Interacting with the database in Python is made easy with libraries such as SQLite, which is a lightweight disk-based database that doesn't require a separate server process. Here's a step-by-step example of how to use SQLite in Python. Firstly, we connect the database. We use SQLite module to connect the database. If the database file doesn't exist, SQLite will create it. Next, we create a table. We use the SQL commands to create a table within the database. Thirdly, we insert data into the table. Insert data into the table using SQL insert statements. Fourthly, we query the data, which essentially means retrieving the data using SQL select statements. After that, we close the connection because you should always close the database connection when you are done. Here's a complete example of how it's done. In this example, we first import the module SQLite 3 and connect the database example.db. We create a cursor object to execute SQL commands as we have done over here. The create table command creates a new table if it doesn't already exist, which happens over here when we execute it. We then insert two records into the user table. After committing all the changes with con.commit, we query all the records from the users table using select.fromUsers and fetch the results with cur.fetchAll. Finally, we print the result and close the database connection with conclose. We print it over here and we close the connection with conclose.
How do you work with JSON data in Python? And can you show me how to read and write JSON data into a file?
JSON, JavaScript Object Notation, is a popular data format for exchanging information between web clients and servers due to its lightweight and human-readable structure. In Python, the JSON module provides function to work with JSON data, making it easy to parse, manipulate, and generate JSON. Here's a demonstration of how to read and write JSON data in Python. Firstly, reading JSON data. To read this kind of data, you use the JSON.load function and parse a JSON file, or the JSON.loads function to parse a JSON string. To write JSON data, you use the JSON.dump function to write a JSON file, or the JSON.dumps function to convert a Python object to a JSON string. Here's the complete example. In this example, we start with a JSON string containing the information about a person. We use the JSON.loads function to parse this string into a Python dictionary. We then access and modify the data within the dictionary. To convert the dictionary back to a JSON string, we use JSON.dump, specifying indent 4 for pretty printing. And to write the JSON data to a file, we use JSON.dumps. And to read JSON data from a file, we use JSON.load. This example demonstrates how to seamlessly convert between JSON and Python data structures, which is essential for working with APIs, configuration files, and data exchange in web applications.
What is web scraping and how would you perform web scraping in Python? Could you please provide me with an example using libraries like Beautiful Soup and Scrapy?
Web scraping is a process of extracting data from websites. It involves fetching the HTML content of web pages and parsing it to extract the required information. In Python, libraries like Beautiful Soup and Scrapy are commonly used for web scraping. Essentially, Beautiful Soup is a library that makes it easy to scrape information from web pages. It works with HTML and XML files, providing Pythonic ways to navigate and search the parse tree. Here's an example of web scraping using Beautiful Soup. In this example, we use the request library to send and get requests to the URL and fetch the web page content. We then parse the HTML content using Beautiful Soup, which allows us to navigate the parse tree and extract data. We find the title of the web page and print it, and we also extract and print all the links or A tags on the page. Next, let's do this using Scrapy. Scrapy is a more powerful and flexible framework for web scraping since it's designed for large-scale web scraping projects and supports features like handling requests, following links, and storing data in various formats. Let's take a look at an example for Scrapy. In this Scrapy example, we define a spider called example spider with a name attribute and a list of start URLs. The parse method is the callback function that processes the response from the web page. We use XPath to extract the title and all the links on the page over here. Now it's important to note that this line is not written in the code, whereas once you reach this point, you open command prompt and write this last line, scrappy come spider example.spider.py. This is written in the command prompt. Both Beautiful Soup and Scrappy are powerful tools for web scraping in Python, and the choice between them depends on the complexity and scale of the scraping task. Beautiful Soup is great for smaller and simpler tasks, while Scrappy is better suited for more complex and large-scale projects.
Well, Amitabh, how do libraries like NumPy and Pandas assist in data analysis in Python? And I would like you to describe the concept with the help of an example with real-life implications.
NumPy and Pandas are fundamental libraries in Python for data analysis, each serving unique purposes and complementing each other. Firstly, let's start with NumPys. NumPy, or Numerical Python, is a library for numerical computing. It provides support for arrays, matrices, and high-level mathematical functions. NumPy's array objects are more efficient than Python's built-in lists, especially for large datasets, and here are some key features and real-life implications. Number 1. Multi-dimensional arrays. NumPy provides the ND array object, which allows for efficient storage and manipulation of large arrays and matrices in numerical data. Secondly, mathematical functions. NumPy includes a wide range of mathematical functions enabling complex calculations on arrays and matrices. For example, you can perform element-wise operations, linear algebra, statistical operation, and Fourier transforms. Essentially, NumPy operations are implemented in C and then optimized for performance, making them much faster than the equivalent operations just in pure Python. In data science and machine learning, NumPy is often used to handle large datasets, perform mathematical computations, and pre-process data. For instance, in image processing, NumPy arrays can efficiently store and manipulate pixel data. In financial analysis, NumPy can be used to perform complex calculations on large data sets of stock prices. Next, let's take a look at Pandas. Pandas is a powerful library for data manipulation and analysis. It's built on top of NumPy, and it provides data structures like series and data frames, which are designed to handle data intuitively. Series is a one-dimensional labeled array capable of holding any data type. It is similar to a column in a spreadsheet, and a data frame is a two-dimensional labeled data structure with columns of potentially different types. It is similar to a table in a database or an Excel spreadsheet. There are a few things that NumPy and Pandas really help us when it comes to their key features and real-life implications. First is data cleaning. Pandas provides functions to handle missing data, duplicate data, and various other data cleaning tasks. For example, you can fill missing values, drop rows or columns with missing data, and interpolate values. Pandas also helps with data transformation because you can easily transform data using operations like merging, grouping, pivoting, and reshaping. This is essential for preparing data analysis or for visualization. Lastly, Pandas also helps in performing exploratory data analysis with its powerful aggregation and filtering capabilities. You can calculate descriptive statistics, create pivot tables, and generate time series analysis on the go using Pandas. Let's take a look at a brief example demonstrating NumPy and Pandas. In this example, we use NumPy to create an array and perform an element-wise squaring operation. And then we create a Pandas data frame to store and analyze the employee data, calculating the average salary. Over here in this code, we import NumPy as MP, then we import Pandas as PD. In the variable data, we add a NumPy array of 1, 2, 3, 4, and 5. Then we print this NumPy array and the data variable we have stated above. Then we print the string squared array, and then we use a function from the NumPy module np square in which we are squaring the data. We then move on to data frames using Pandas. We say df is equal to pd.dataframe, and then we input the values we are adding into the data frame into the rows and columns specifically. After that, we print data frame, move on to the next line, and in the next line it will print all the data frame values we have stored in df. After that, we print average salary, and after that we choose df salary. So it will print out the salary portion of the data frame while taking account its mean, because we've added the mean function from the module. As a result, here we are showing how these libraries streamline data analysis tasks and make it easier to derive insights and make data-driven decisions.
Could you show how to create a 2D array and perform matrix multiplication using NumPy libraries?
Certainly, creating a 2D array and performing matrix multiplication and other complex tasks is very simple in NumPy. Let's take a look at this in the form of an example. Over here, we import NumPy as NP. We assign matrix 1, the variable over here, an NP array of 1, 2, and 3, 4. Then in matrix 2, which is another variable, we assign an NP array of 5, 6, and 7, 8. Then we print out matrix 1, and in the next line, we print out the data that is stored within the variable matrix 1. After that, we print matrix 2. In the next line, we print out the data that is stored in variable matrix 2. We assign the variable result np dot matrix 1 matrix 2, which is essentially a form of showcasing the two arrays using the dot function in NumPy. Then we print out matrix multiplication result next line, and then we print out the result which we stored over here. So as a result, the output will be matrix multiplication result, and then in the next line we'll see the multiplication of matrix 1 and matrix 2, which are given values over here.
Well, suppose you have a CSV file named data.csv with certain elements like name, age, and salary. Find the average age, the average salary, and also determine the standard deviation of ages and salary. I would also like you to give it a shot to calculate the correlation coefficient between the age and the salary.
Absolutely. This is a great exercise to illustrate the integration of pandas and NumPy for data analysis. Let's go through each step. Step 1. Read the CSV file into a pandas data frame. First, we'll use pandas to read the CSV and create a data frame. Let's take a look. Over here we import pandas as bd. Here we create a variable df where we write bd.read CSV data CSV. We have a file of data called data CSV, and we are asking pandas to read it for us and then storing the values in the variable df. After that we print df. We get an output of name, age, and salary as the columns, and 0, 1, 2, 3, 4 as the rows. Over here we have this corresponding name, age, and salary for each row and column. Then we move on to importing NumPy as NP. Over here we create a variable called ages where we say df age to NumPy. Same thing we do with salaries. We create the variable salaries and we say df salary to NumPy. Then we print ages and the data stored in the variable ages. Then we print the string salaries and the data stored in the variable salaries. Essentially what we are doing over here, we are stating these variables and saving the data from the data frame corresponding to the column of age to NumPy. That's the data we are storing in these variables. The output of printing these two will be ages is 25, 30, 35, 40, 45, and the salaries will be 70,000, 80,000, 90,000, 100,000, 110,000. The reason we have this is because over here we have called these ages and these salaries over here. Now the part 2 of this question is calculating the average age and salary. So now we take a variable called average age, and over there we put np.mean ages. Ages is the variable we defined previously before. Right, over here we have average salary, and we do the same thing with the variable we defined before called salaries. Over here we print average age, the string average age, and then we call average age variable that we have stated over here with the data we have assigned to it, and then we do the same thing for average salary. After that we take a look at standard deviation of average salaries. It's essentially the same thing we have done above. We take standard deviation variable, we assign it the data of np.std, which is the function for standard deviation in the NumPy module, and then we assign ages, the variable we defined before, which will call the data within that variable. Then we move on to doing the same thing, standard deviation salaries, np.std salaries. Then we print out the string standard deviation of age, and we call the variable we have defined before standard deviation age. Then same thing we do with standard deviation of salary, where we print out this string and we call the variable standard deviation salary. As a result, we calculate the standard deviation for ages and salaries. Lastly, we calculate the correlation coefficient between age and salary. Over here we define a variable called correlation. Here we say np dot the function correlation coefficient, which is called corcoef, and within that we put ages and salaries, where we are calling the columns from the data frame. Then over here we say 0 and 1, which is the range. So we are defining a range of 0 and 1. Then we go ahead and print correlation coefficient between ages and salary. This is a string, and then we call this correlation variable that we have placed it over here. The output will be average age is 35, average salary as 90,000, standard deviation of age, which is over here 7.071, standard deviation of salary, which is 14,142.13, and correlation coefficient between age and salary is 1. As a result, we are able to show a positive relationship between age and salary, and we are able to analyze data using NumPy and Panda in the same code.
How do you visualize the data using Matplotlib and Seaborn? And can you show an example of a simple plot?
Sure, I can talk more about Matplotlib and Seaborn. Matplotlib is a comprehensive library for creating static, animated, and interactive visualizations in Python. It is extremely customizable and it works well for creating detailed plots. Let's take a look at an example using Matplotlib. In this example, we have imported matplotlib.pyplot as plt. This is the name of the module. Over here, we have created a variable x, created variable y, and we have assigned them this data. Now over here, we'll say plt.plot, which is a function within the matplotlib module to generate the plot, where we have added the two variables we have defined before, x and y, and we have written marker is equal to 0. Next we have plt.title, which is another function within the matplotlib module, and over here we've added simple line plot, the string. This will be the title for the graph. Then we'll name the x-axis and y-axis by saying plt.xlabel is the string x-axis, plt.ylabel is the string y-axis. After that, to show the graph, we have to type in plt.show, which is what allows the code to print the graph. Next, we'll take a look at Seaborn. So Seaborn is built on top of Matplotlib, just like Pandas is built on top of NumPy. It provides a high-level interface for creating attractive and informative statistical graphs. It integrates very well with Pandas data structures, and it makes it easy to create complex visualizations with less code. Let's take a look at an example to understand how Seaborn works and how to create a bar plot in Seaborn. In this code, we'll be importing Seaborn. In this code, we'll be importing Seaborn as SNS. We'll be importing Pandas as PD as always. Here we create a variable called data, and we are assigning a data frame inside the data variable. It will have this data in dictionary form, category, value, and the assigned data within it. After that, we'll go about creating a bar plot, where over here we'll do sns.barplot, which is a function that is within the Seaborn module. Over here we'll take x is equal to category, y is equal to values. Over here we are essentially defining the parts of the bar plot and what values it assigns to. And then we say data is equal to data, which is the variable we have defined over here. Then we move forward and give a title to the graph, which should be simple bar plot. After that, we'll name the x label as category and y label as values. Then we'll go ahead and call this graph by typing plt.show. As a result, now you can use Matplotlib, Seaborn, and Pandas to show how you can add information and data into data frames, and then you can utilize that complex information to create easy to understand graphs using Matplotlib and Seaborn.
Well, do you have any questions for us before we conclude?
Yes, I do have a few questions. Firstly, I would like to understand what kind of projects will I be working on if I was to join your team. Secondly, I was hoping to understand a bit about how the team is structured and what kind of code bases do they work on. Lastly, I was hoping you could tell me a little bit about the working culture within the company and what benefits are provided if I was to join this job.